Algebra 1A, what's up? All right, so we've solved systems with graphing. We've done it with substitution. Today we're going to learn elimination. Quick review. I also learned on these videos, I say a lot. I apologize for that. I'm going to work on that too. So we're going to do elimination today. The thing with elimination is elimination works very well when equations are in standard form, meaning they're not in slope-intercept form. They have their x and their y on the same side. Quick recap, when we're solving systems, we're solving two linear equations and we are looking for their point of intersection. We graph a linear equation because it shows us those infinite amount of values that make it work. We're looking for the very point where they cross that makes them both work. So there's either a point of intersection, or else they're parallel with no solution, or they're the same line with infinite amount of solutions. Now, I'm hoping you did the pre-elimination exercise that we were doing. What that should have showed you is that if I have an equation with a certain solution and another equation with that same solution, when we add them together, we get a third unique equation that also has the same solution. That's going to help us with what we're doing today. So up on the board, I have two linear equations, and we want to solve this system, and we're going to do it by elimination. Elimination is the process of adding equations together and getting a variable to eliminate. So if you look at the example we have here, this guy has a 9x, this guy has a negative 9x. Now when we add those together, the 9x's are going to cancel out. That's going to eliminate an x, and it's going to give us a third unique equation that is solvable for y. So here's what we're going to do. We're going to add these two guys together. When I do that, my 9x plus my negative 9x, they're going to eliminate. My 2y plus my 4y is going to give me 6y. My 15 plus my 3 is going to give me 18. So by adding those together, we eliminated the x, and we now have a single equation, very simple equation, with just a y in it. It's solvable for y. So to solve this for y, we divide by 6. We wind up with y equals 3. Just like substitution, when we get that y equals 3, we now can take that, substitute back into one of the equations, and solve for x. I would assume we would all choose the top one. A little bit easier. It doesn't have that negative 9. So I'm going to take that 9x plus 2y equals 15. Since I now know that y equals 3, I'm going to substitute that into here. 9x plus 2 times that 3 is going to equal 15. So, quick multiplication. We have 9x plus 6 equals 15. We now should be able to solve that for x. Two-step equation, very easy for us. We will subtract 6 from both sides. We'll wind up with 9x. 6 is eliminate. Equal sign comes down, and 15 minus 6 is 9. Finishing that up, divide by 9, divide by 9, x equals 1. So once again, we have our point of intersection. It is 1, 3. That is the solution to the system. So we'll put it in a set of solution brackets. Easy enough, right? Most kids seem to like elimination better than substitution, so I think you'll find this easy. Now the unfortunate part is, are they all going to be that easy? Are they all going to have x's that have opposite coefficients, so when I add them they eliminate? No, but we can make that happen. Let's move on. So the second example I have is going to be 5x minus 3y equals 5. 5x plus 2y equals negative 20. Now, when I look at this, the difference is when I look at those x's, well, they're both 5s, but if I add them together, they're not going to eliminate. One has to be positive 5, one has to be negative 5. So what we're going to do is we're going to fix that. Sometimes teachers will teach that you can subtract these as well. I like to avoid that. I think a lot of mistakes happen that way. So instead of subtracting them, I'm just going to make one the opposite and add them. So all I'm going to do is I'm going to choose one of these guys to multiply by -1. In this case, it won't matter which one because one of them will turn into -5, the other one will stay put. I'm going to elect to take the bottom one and multiply it by -1, but we could do either. So I'm actually going to show that and show the distribution. The biggest mistake I see being made, students choose the correct thing to multiply. They multiply one side of the equation, but not the other. Make sure you multiply the entire equation. So I'm going to make a little line here. The first one we did not change. It just comes down as 5x minus 3y equals 5. The bottom one we're going to multiply by -1, so we're going to distribute that through. That becomes -5x minus 2y equals 20. Lots of room for simple mistakes here, so be careful. At this point, I now should be able to add these together and have something eliminate. When I add them together, the 5x plus the -5x does eliminate. That's what I wanted to happen. The -3y plus -2y gives me -5y. And the 5 plus the 20 is 25. Once again, real simple equation to solve. Divide both sides by -5. -5's will eliminate, and y will equal 25 divided by -5 is -5. Just like before, once I have one variable, substitute it into one of the originals. Avoid going to one of the ones you multiplied. If you made a mistake there, you will not find it. Take it and go back to one of the originals. So we'll take the original 5x minus 3y equals 5. And we're going to substitute that y equals -5 in there. So this is going to become 5x minus 3 times that -5 equals 5. Simple multiplication there. This is 5x. -3 times -5 becomes positive 15. And that equals 5. Two-stepper there. We should be able to turn and burn through that. Subtract the 15. That's going to give me 5x. 15's cancel out. That equals -10. Divide by 5. Divide by 5. And x will equal -2. Hope you can see that. So, got my solution here. I've got a solution set, -2, -5. Again, if you wanted to, you could check your work. Take both of those, plug it into the other equation, this bottom one we didn't use yet, make sure it works for that. I think you'll find out it will. Both of these would turn into -10, -10, -10, and of course adding those together gives you -20. Cool? Cool. Let's move on. Now, sometimes you get equations and they don't even have the same coefficient. So we're going to have to multiply more by more than just a negative. So my third one, I have 3x plus 2y equals -2. I have x plus y equals -2. So I want to solve this guy. The only thing is, if I try to eliminate this, adding those together accomplishes nothing. So what I'm going to do is I'm going to say, well, I want to eliminate something, so we've got to multiply one of them by something to make it eliminate. Since both of these guys have coefficients of 1, I think it's going to be easiest to multiply that equation by something. So what I'm going to do is I'm going to choose to either eliminate the x's or the y's. You can do either. The first two examples we only did the x's, but we can do either. So we're going to go after the y. I want to multiply this equation by something that will make the y's cancel out when I add them. Obviously, since this guy's 2 and this guy's 1, I could turn this bottom equation into that coefficient being a -1, or a -2, sorry. So I'm going to multiply by distributing by a -2. If you're a little confused, just hang on. So the first one we didn't change. The bottom one, I decided to multiply through by -2. When I do that, I would get -2x plus a -2y or -2y, whichever one you prefer, and that will equal +4. If you notice what happened, choosing to multiply by -2 made that a -2y. Now when I add these, those guys will eliminate, and that's what I want to happen. So I'm going to add these two equations together. 3x plus -2x is 1x. 2y plus -2y, well, that eliminates, and that's what I wanted to happen. Equal sign comes down, and -2 plus 4 is +2. That's just 1x equals 2, which is the same thing as x equals 2. And like all the other ones we've ever done, as soon as you get one variable, go back to one of the equations, solve for the other variable. I'm going to take the x plus y that we originally had. X plus y equals -2. I'm going to take that x and I'm going to substitute it in there. 2 plus y equals -2. I'm going to subtract 2 from both sides. I'm going to have y equals -4. My point of intersection is 2, -4. That is the solution to the system. So it gets its set brackets. Hopefully that seems fairly easy to you. We're going to do one more example, and then you're going to give it a try. Last example, 2x minus 5y equals -12. 3x plus 4y equals 5. Now the problem is nothing's even close to being the same. What are we going to do? Well, in this case, it might be necessary to multiply both equations by something. So you're going to have to make a decision here. What I'm going to do is I'm going to survey my problem here. I'm going to look at the x's, 2 and a 3. I'm going to look at the y's, -5 and 4, and I'm going to make a decision. What seems easiest to eliminate? Now, we could go after either. You can do either. You can get the right answer either way. It's all just what you think seems easier to you. I'm probably going to take a look at that and say, well, since this guy's already negative and this guy's already positive, I'm going to go after the y's. I'm going to multiply this top equation by something and the bottom equation by something to have them eliminate. So searching through the multiples of 5 and 4, I realized that I could turn them both into 20. One -20, one +20. So what I'm going to do is I'm going to multiply the top one by 4. I'm going to multiply the bottom one by 5. That should give me a -20y and a +20y, and then they'll eliminate. Again, make sure you multiply the entire equation. Don't forget what it's equal to on the other side. Multiplying the top one by 4. Let's switch to purple here. 4 times that mess, 8x minus 20y equals -48. Bottom one, 5 times that guy, 15x plus 20y equals 25. So now what we're going to do is look at that and say, when I add them together, will something eliminate? If the answer is yes, which in this case it is, keep going. If not, you multiply by the wrong things, you need to make a different decision. We're going to add these two guys together. If I take 8x plus 15x, I'm going to get 23x. -20y plus 20y eliminates. Equal sign comes down. -48 plus 25. If you don't have your calculator, you should be able to do that without it. That's going to give me -23. So Super simple, easy problem to solve. Divide both sides by 23. And bring the x closer here. 23's cancel out. That's going to equal -1. Again, once you get one of those variables, make sure you go back up to one of the original equations. Don't use one of these. Choose whichever one of the original equations you think looks easier. I guess I would go with the bottom one just because there's not a whole lot of negatives in there. Not that either one's that difficult. Well, I didn't leave myself much room, did I? So, I'm looking at 3x plus 4y equals 5. I'm going to put the -1 in for x. And then I'm going to solve. 3 times -1, -3, plus 4y equals 5. That's a two-stepper. Let's add 3 to both sides. I'm looking at 4y equals 8. Dividing both sides by 4. I'm all but out of room. Y equals 2. So now that should be my point of intersection. -1, 2. That's the solution to the system. Give it some set brackets. If you want to check, take the -1 and the 2, put it into the equation you did not use to solve here, and make sure it works. You would wind up with a -2 here when you put a -1 in there. You'd wind up with a -10 there. -2 and -10 would give you the -12, so it does work. All right. Hopefully you noticed I'm working on trying to get transitions into my videos and make them a little more, I don't know, professional and appealing. So hopefully you saw that in the last video, and hopefully you'll see it in this one. If not, I apologize. I'm trying to make them a little more fun and professional. So here's your try. You're going to do 2x plus 5y equals 38, and 3x minus 4y equals -12. You know the drill. Pause the video, give it a whirl, come back, we'll check your work. Welcome back. So what I did, since you can go after either variable, is I did it 2 different ways. So in the first one over here on the left-hand side here, I went after the y's. So to make the y's cancel out, I multiplied the top one by 4, the bottom one by 5. When you do that, you're getting 8x plus 20y equals 152. And then in the bottom equation, you're getting 15x minus 20y equals -60. When they are added together, you get 23x equals 92. The y's eliminate. You solve for x, you get 4. And then of course you would take that, plug that back in. I couldn't show all that, my board's only so large. But if you were to plug that back in, for instance, if I put an x4 in there, 2 times 4 is 8. If I were to solve that, subtract 8, I got 5y equals 30, divide by 5, y is 6. So you should have gotten 4, 6 if you did it that way. And if you did it that way and you're good with it, awesome. If you decided to go after the x's, and this is worth watching, you could have multiplied by 3 and 2. The only thing is one of them has to be negative. I chose to make the bottom one negative because it already had a negative in, or had 2 negatives in, so they would turn positive. It actually gets a little easier, I think. But you could have multiplied this guy by -3. I just can't show all the different variations because we'd be here all day. So if I do that, I get 6x plus 15y equals 114. -6x plus 8y equals 24. And then when I add them together, I'm looking at 23y because my x is canceled out, and 138. Divide by 23, we get y equals 6. And then of course plug that back in, solve, you would have found out x is 4 however way you did it. So I hope that makes sense. Keep in mind there are no solution, an infinite amount of solutions. We know when they pop up. If everything eliminates and what's left is true, infinite amount of solutions. If everything eliminates and the statement left is false, like 5 equals 16, no solution. We know these things. Good luck. Try your problems. And I'll put more examples up if we need it, or I can help people individually who need it. Good luck. Let me know how it goes. And I'll see you soon. See you guys.